for data science and AI program and also for information management program. Why it is that? What is the course about? Okay, so let's have some quick look together. With this course, it emphasizes on emerging data models. Nowadays, we have we have data available everywhere, right? In terms of computer system, in terms of anything in your mobile device, everywhere. But it is very important for organizations to be able to manage and make use of the data properly. And that is why many of you who study data science program knows, right, that data is kind of, we use the term data is new oil. It's kind of asset. It makes value. So you want to have a chance to be able to manage the data, make use of the data, understand and get insight from the data as much as possible. But before you can actually turn the data into some value, you need to have data first. But you cannot just having any data. The way to manage, the way to collect, to store, to make sure that your data is in good shape, ready for further analysis, ready for visualization, ready for any kind of machine learning model, prediction model, and so on. The starting point is to have good data. So we will learn that how can we will learn about data models. We will learn about technologies that allow you to manage the data, to properly model the data according to the different types, format, structure, and so on. Okay, so that is the motivation why this course would be relevant to data science. And the same for information management. You make use of data to create value for business organization. We need to make sure that we can apply the proper technology to manage data well. Okay, and there are many types, different types, different characteristics of data. So there are different proper technologies that can be used for these different types of data. Okay, such as data can be textual, data can be image and photo, also kind of data, right? Voice is also a kind of data. Even if it's not in terms of textual format, they are also data. Even we talk and even though we talk about the textual types of data, still some data has very rigid structure, well structured. Some types of textual data may have very poor or no structure at all. So they require different ways of managing and different technologies to properly store them, query them, analyze them, and so on. Okay, so that is what we will learn in this course through different possible models and techniques for managing different types of data. Okay, and that means we will learn the model. We need to be able to we need to be able to choose the right technology for the right problem and the right requirement. When you have these types of data with these requirements, okay, this technology A is the most appropriate. When you have these types of data with these characteristics and so on, maybe technology B is more appropriate, something like that. We need to be able to choose the right technology. Okay? So the learning outcomes for this course start from, of course, understanding different data modeling and management concepts. Design and organize various types of data using proper models. We will cover two types of models, two broad types of models. One is relational model, very well structured kind of model, right? Another is called non-relational model. To be specific, the NoSQL one. Okay? And we need to be able to analyze characteristics, requirements of given data. As I said, data can be of different types and formats and structures and characteristics. Which model is best for these types of data. Okay, should be able to analyze and choose the right one. You will need to do some, make your hands dirty, not only theoretical analysis and so on, but you need to practice on certain lab sessions in order to implement some of the models using some of the tools, demonstrate how do you access the data, store the data, collect the data, and make use of the data, transform the data, and so on. Okay. We will have some of the special topics, but not very deep detail, because then otherwise, I mean, each of some of these topics that we cover, some of them we can go deep to some extent. Some of them we can go a little bit overview and pretty shallow, but make you aware, let you aware of the technologies or the topic, okay, in which it's a starting point for you to go deep later on in some other courses or in your own research or thesis that you would do. Okay, so that means we may cover the big data. We will discuss about big data, certain data governance and issues, data privacy, data security issues, but in a pretty overview manner. And yes, some of the data engineering and data visualization concepts. Okay, so for the course outline or the topic that we will study together, okay, they are divided into eight main topics. Okay, some we can go deep, some we will go, as I said, a little bit broad. The very first topic, if you have background in computing related program before, I mean your bachelor program, for example, I think the first topic is something very much familiarized to you. That is relational data model and management, or SQL model. Okay. We will go over this as a recap, and also for those who are new, even for those who are new, they are not very difficult, but also when you are new, everything seems to be challenging. So there might be some extra review and readings that you may need to prepare, but we will cover basic stuff and basic foundation, okay, to make sure you are able to understand the topics of relational model, because even there are many other types of emerging data models. Relational data model is still the very one of the most important nowadays, because most of the data is still well structured in many of the organizations, and the technology is very mature. The performance is very good. So relational model, even it has been there with us for 20 years plus and so on, right? Still they are very good. I don't think 20 years, even longer, older than that, right? Then we will cover NoSQL data modeling and management as well. In particular, we will cover 4 types of NoSQL: key value, document, columnar, and graph. We'll learn about how do we design, how do we implement. So we learn not only the theory and application, but we need to really implement and create something, design and develop something. We learn about data distribution, transaction processing models, and large-scale data handling related to big data requirements. Okay, application case studies of different types of data models and technologies. We learn about data engineering techniques. Okay, which are very much required and important when you are in data analytics process, when you want to build model for predicting, making use of data analysis, and so on, before you can do anything, your data must be in good shape, as I mentioned. So data engineering is kind of preparing data for the prediction model, for the analysis model. Okay, and some other related topics. Okay, introduction to other related topics, including security, privacy, certain legal issues, some of the case studies related to data governance and privacy. Nowadays, I think data privacy is a big topic as well, right? We have in Europe, we have GDPR, in Asia, in Thailand, we have GDPR and so on. I said GDPR, I should say that. Okay. Anyway, here, my name and my email address. Sorry, the online students that I forgot. Okay. Here, my name, as I said, you can call me just Dr. Shutipan, and my email address is by my kind of part of my first name, Shuti@ait.ac.th. And when you learn more, you know that I have 2 email addresses somehow, but it's fine. I check both. You don't need to worry somehow when we know that, okay, that person has 5 email addresses. When you have important things to inform, right? You are afraid that the person may not get it. You send to all the 5 addresses. Send to me one is enough. I am accessing and reading every email, but somehow I perhaps do some classification. This kind of email is for what purpose or something like that. Okay. All right. Warm up discussion. What you're thinking of when we talk about data? In the class, you can feel free to say out loud. In the online, you can also turn on the microphone and say it, or type in the chat. I need to open the chat a moment. Okay, sorry, maybe my question is not so clear. What kind of data, what kind of things you are thinking about when we talk about data? What data you have in mind, or what kind of thing? Okay, Mary said it's information that is stored somewhere that can be transformed and processed. And data is facts about something, calculating, reasoning, or analyzing. Thank you. Okay, anything else? It may be definition, it may be example of data, it can be things related to data, it can be anything. What do you think of? When we hear of the word data? Yes? Okay. This is a question or this is sharing? Yes. Okay. Yes. Thank you. And your name, please? Ramen. Okay. Sorry if I pronounce some of your name wrong. I try to correct and I try to see the list and make sure that I can read and pronounce correctly as time go by. Okay. So he mentioned about sensor, data from the sensor, even from body sensor, right? Yeah. This is also example of data. Other kinds of data you're thinking of from others? Okay, thank you. Yes. Value data we store and can extract useful and generate and make useful information. Thank you. Actually, but this is also things we have to be careful. When students say something in the class, we hear. And when the online students say something, we also hear. We are in the class. But one thing is that when students say and I say, if I'm not on a microphone, the online student will not hear anything. So that will be something we may need to, it may not be easy, right? That every time everyone wants to say something, you need to come run and grab a microphone. I don't want to make that kind of difficult way to participate in the course, in the class. But for some long discussion and valuable things, maybe we need to use the microphone to let the online students hear as well. So from online, anything else? Facts, information, statistics. Any information can be called data. Okay, healthcare related data, patient report, age and name. Okay, thank you. Very good. I think you have an idea. What is the data and what kind of data you have about, right? And if I think about data, because I teach data modeling and management, these are the things that come up to me in my mind as well. I may think about several types of data, examples of data, as you mentioned. I would think of technology related to managing and modeling, handling data as well. So this, and I may think about characteristics of types of data, such as what we will learn is about semi-structured data, structured data, unstructured data. This is some kind of some way to classify data. Okay, so we are aware that when we talk about data, right now we are in the era of what we call big data, right? And that means data that is available for us now is huge. Where are they from? Think about the source of data. Where do data come from? We admit that data are huge, but who generates the data? How data is generated? From which sources? What do you think? From the environment itself. How come that we have that data from the environment to be in a computer then? Okay, perfect. Yes, if it is from the environment, we use some kind of sensor to extract, grab the data, store them, such as yes, a speeding. Okay, speed of a car. Thank you. Yes. How about the other ways? So some sensor generating data. What else? Transactions. So human transactions. I mean, human is the one making a transaction. Okay, such as okay. Yes. When you do things online, you do generate or make certain transactions such as bank transfer, buying something online, right? All these kind of transactions is a kind of data that is stored in a computer somewhere, somehow, right? And it's real data stored. Anything else? Okay, Israel said it's a machine human interaction from everywhere, from report. Okay, books, reports, everything human make, we generate the data, right? I mean, we create, and then that is also considered as data. Textbook, anything you create, you produce. How about video clip, YouTube? Are they data? Video clips on YouTube? If you make a video, right? You make a video, TikTok, for example, TikTok videos, you generate it, you store it, you upload it, you share it. They are also the data coming from humans, not only in form of textual report. Okay. Anything else others want to share? Natural events. Okay, yes. And of course, similar to correct? Okay. It's the same, the data from the environment that we need certain small device, sensor, and so on to detect or grab and generate the data. Okay, so I can summarize into three major sources. I say major because it means that there can be more, right? But these are three main sources that we have seen how data are generated, such as what is here has been shared from machines. The tools, the device, the sensor, these are the machines, right? Even the computer weblog, when you access web server, when you browse a website, your history is logged, right? These are the logging data that is generated, recorded, stored in the machine, and generated by the machine. So data generated from real time using sensors, machine, vehicles. Another source is from people, as we already discussed. You may post certain social media updates. You may share photos, video, any kind of media data, personal use as people. From organizations in terms of kind of official formal records of certain things, such as transactions, business transactions. Okay. So these are the three major sources. And we need to be able to manage them. They are different. They are from different sources. The way to manage them, the structure of these data are also very different. So when we do the management, data management, there are different perspectives and contexts that we may need to be to concern, to be aware of. Okay? That is, there are organizational context. It's related to the process and people. Okay. There are technological contexts that you need to be involved. As a technical people, we more or less think of data management in the sense of technological context in terms of the design of the system, storage of the system, and so on. In terms of the decision making, we make use of data to support decision for sure. Otherwise, that is not the value of data, right? You need data to support decision. So it is in the aspect of utilizing, using the data. Okay. And there are, all these details, okay, we can read and find out later on. So if we talk about the usage in terms of the data-oriented perspective. Sorry. Okay. There are even the accessibility to the data, whether how do we define accessibility? If we focus in terms of the analysis of the data, there are many ways that we can analyze and use the analysis results, right? Such as making predictive analysis to forecast something, to simulate, and to optimize, to analyze the text, and so on. Okay. If we talk about delivery, meaning visualizing, presenting the data to other users, of course, is the dimension that involves, for example, making a dashboard, making graph presentation, visualization. Okay. In terms of design and storage, of course, there are a lot of things. This is very technical as well. You want to, okay. And if we talk about process and people, this is the way to manage the data in terms of the organizational related context, right? You need to define who can do what. Okay, who has the role of doing something with the data, who has access role, who has decision making role, and so on. Okay, and as I already mentioned, is data is very important nowadays, and to everyone, not only nowadays, from the past, data is also important. The main role of data, why it is important? Because it supports decision making. Not only organization or enterprise, but this pyramid reflects how data is supported in the organization and divided into different levels. But even for yourself, do you use data for making decisions? Sure, right? Albin, what data is used for deciding to join AIT? Any key decision making, a key factor when you apply to somewhere, right? You already make decision that you're interested in studying at AIT, for example. At least you make the very first step decision. Once you get admission letter, maybe you need to consider several other things, right? More and more detail. And you still need decision data to support your decision to finally confirm you're coming, right? Everything, every decision you make, small or big, is based on data. If you have enough, even more data, the decision you make should be better, right? Less data used to make decision, more data used to make decision. I think you have different quality of decision. Okay. The same in enterprise. We can divide the data into three. We can divide the enterprise structure of the organization into three levels. The top level, of course, is strategic level, executive people, top management of the organization. In the middle level, if we think about decision, it's the kind of tactical decision, the management level, this middle management level. In the very lowest level, it's just the operational, just routine work, routine decision. Even the routine work, you still need to make decisions, right? But it's easy. The lower the lower in this pyramid it is, the types of decision has more structure. For example, if I am a seller in 7-Eleven. Have you visited 7-Eleven already? That is the landmark of AIT, one of the landmarks. I think every student somehow I saw somebody told me yesterday that in the morning, oh, it was one of the popular places. Students went for maybe buying something for breakfast, easy breakfast, quick breakfast. Okay, anyway, if I work in 7-Eleven at the cashier, I also make decisions. I also do my work, right? But I am in this very level, low level. The decision is perhaps what to sell, what to do, what to plan. Even some simple stuff like you give me 100 baht, how much do I need to exchange you? What else do I need to do based on this and that? I make decisions, but they are very structured and easy decisions. The system that manages the data is just a transaction processing system. There are fixed rules, fixed methods, fixed way of developing the system, right? We record sales, transaction, we record the income or revenue of each day, we record who comes to work, right? Cashier number 1 is Chutipan and so on, work from 8 o'clock to 4 o'clock. These kind of things are very routine and operational related. And the data that is managed, still it involves data, right? Is managed by transaction processing system. When it is the middle level, the types of decision involved is somehow semi-structured. It's not very well structured. It's not predictable. And it doesn't have just one answer. Somehow it's kind of semi-structured. So it could be something like, what kind of product you decide to bring into your shop, your 7-Eleven. You have million variety of products you can order into your shop, right? But and which one and how many? This is somehow could be semi-structured. Of course, some could be based on the purchase history, right? Oh, students love Coca-Cola, for example. Okay, then we buy more Coca-Cola for sale. What kind of promotion you should have? Suppose if you are the owner of this small shop, then maybe this is the semi-structured decision you make. The highest level, okay, sorry. Then the system that support you and analyze the data, manage the data for you is called management information system. It can make you, as I said, a report of daily sales by product, item, product category. So you can see it's likely that if you buy more of Coca-Cola, you can sell more and make more money, for example. Or you can see that how many students come during the evening time. Oh, evening time, it may be a peak period. 1,000 visitors come. You may need to hire more cashier, more staff during that period. And during the daytime, maybe very low number of customers, you reduce the staff, or even at the nighttime, whether it's more or less, something like that. This is also the decision you have to make. And the system that support you, as I said, it generates certain kind of report, analyze some statistics, some data analysis, and present to you as the middle manager. Next, decision support system for the top management with the types of decision which could be unstructured decision. How about if you want to invest a new 7-Eleven? Should we do that? This is unstructured decision, and it is not easy decision like how many staff we hire from 8 o'clock to 12, how many staff we should hire from 6 o'clock in the evening to midnight. That is the middle level, right? What product you should buy more and stock more, that's also middle level. But to expand the branch to another location, should we do that? And so on. This requires more of the data to support you. It may involve prediction of customer needs in the area, in the new area, right? You need that kind of data, whether it's available or not. That is the data that perhaps is available will support you. As I said, the more data you have, the better decision you make. But sometimes you may not have that data, right? How can we know how can we predict market demand? You may need to predict market demand so that you make the decision whether you open a new branch or not, right? Okay, anyway, so that is, we are here, actually, we are, how to say, we are the technical people, of course, but we want to develop technical systems. We want to make use of the right technology in order to support all these possible decisions, right? And then you need to know that to support, if we are supporting the lowest level, we design and develop such a system. If you want to support the middle level, we design and develop this kind of system, and so on. But more or less, is a pyramid built on top of one another. We cannot have this system without having the bottom or the lower level system, right? Because The decision of the topmost level, rely on availability of data from the bottom level as well. Okay, so it's a kind of stepping up. You need to build a ground so that you can step up to the second level, third level, top level, and so on. But you need a ground. So we cannot avoid, for example, how can I know that should we stop more Coca-Cola? Okay, very simple. Suppose now Coca-Cola has promotion to our shop. If we order 2,000 bottles, we get special price. Oh, shall we go for it? This decision is not like we go shopping, right? You see on sale, if we are ladies, I think we can talk about this, right? We are sale, we see the post, sale, 50% sale, 70% sale on this and that item. You are likely to buy, right? Whether you want it or not, somehow you are attracted by this sale promotion and so on. The same, Coca-Cola gives you promotion, whether you should buy it. What decision, what data you need to make such a decision? If 80 people, we don't like Coca-Cola, even it's very cheap, you buy it, it's a waste of your money, right? So you need the data. The data comes from transaction, right? You need to analyze purchase history, behavior of 7-Eleven customer in AIT. Otherwise, you cannot make that decision. So as I said, whatever decision you need, rely on the bottom level. Anyway, building up the groundwork. So even this kind of system could be simple, supporting very easy decision, structured decision. It's still very useful and very important that we need to build well. So we need a system for kind of point of sale, right? POS, cashier, so on. Otherwise, we cannot make management report like daily sale, monthly sales, trend of the product that are popular in AIT. Okay, so for the very last type of system, the transaction processing system, sometimes it's called online transaction processing system because right now everything is online anyway, so it's OLTP. The database system technology will be used, kind of key technology that is used to support such kind of system development. So you need to create and design database structure to collect, to host, manage the data. You may need certain database software, application program for the user to make use of it. This is kind of basic architecture of online transaction processing system. Okay. And if we talk about database, for online transaction processing system, in the past, the most popular technology that is used is relational database management system. And these are just some samples of the systems that are widely used, okay, been popular. If we talk about the MIS, middle management information system, the second level, you may nowadays think of business intelligence kind of tool or system, and it may involve, okay, this kind of architecture show you how this business intelligence could comprise of the component of business intelligence system. It involves, of course, several sources, variety of data sources, which could be relational database, which could be NoSQL data source, which could be from variety of sources, even a big data source, even from the cloud and so on. So the data source could come from variety places. And pull into perhaps data warehouse. This is just one possible architecture. What we are proposing or introducing here is just an example. There are very many ways of implementing OLTP, very many ways of implementing business intelligence system. Once you have consolidated, integrated data, you can analyze them together through certain dashboard or many other things. Visualization, dashboard, reporting, and so on. And then the user can make use of them easily. So this is for the second layer, second level, and also the top level. It depends what kind of data, what kind of analysis technique you use to support middle level management or the top level management. Okay, so we can see that all of these require data. Okay, all of the decisions, as I said, structured, semi-structured, or unstructured data, all of them require data. Structured, unstructured, semi-structured, and unstructured decision require data, right, to support the decision. So we need to make sure we model our data very well. Otherwise, processing the data will be a problem. You need a good way to sort your data, model your data, store your data. Okay. What do you think when we talk about data model? What does it mean? It's part of the course title, data model, data modeling. What do we do when we say we are modeling our data? What aspect? How the data will be stored, where it will be stored, okay? How it will be accessed, yeah, okay. Anything else? So it's more or less about the characteristics of the data, the accessibility of the data. Anything else? Structure of the data, thank you. Usually when we talk of the data model, we think of data characteristics. But of course, there are many characteristics that we can talk about. The modeling of the data involves these many types of characteristics divided into three main types. These are the three main types that we will focus in our course. I mean, three main characteristics of data. First, its structure. What is the structure characteristics of the data? Second, what operation you want to do with your data? Different types of data require different operations, right? What are the constraints you have for your data? Okay, let's look at an example. And all the characteristics are different from one application domain from the other to the other. For example, even you're talking about the same data, but when it is used by different applications, maybe they have different characteristics, such as your personal data. If it is for AIT, for you as a student, we may have this kind of structure. Okay, let me send this to students. Suppose we may be interested in only this structure. But if it is another university institution, maybe they have more or less structure, right? Not exactly the same, even it's the same kind of data. Okay, so the structure defines how do you keep and store the data. What kind of things you want to store and keep in your data that can be told by the structure, and what format or what types of structure. Okay. Also, what else? In terms of operations, what do you want to do with your data? Such as if it is students, what do I want to do? I want to add new students. I want to remove students who quit. I want to update student data. I want to summarize count number of students in my department, my program, my classroom, and so on. I want to have a way to select top students in case we have some opportunities that require certain kind of students, something like that. Right? These are operations that are different from one application to another, right? The operations you want to do with the data, it can be related to the types of data as well. If it is this kind of data that is some kind of having attribute and value structure, this kind of data has the structure of attribute, value pair, more or less. Right? The example I show, such as attribute first name, the value is 34. Attribute last name, the value is my last name. Date of birth, my date of birth. This is kind of structure with the attributes and value here. But if I'm talking about my photo as a file, you take a photo of me. It's not attribute and value pair. It's just a photo with its own structure, right? The JPEG photo is not attribute of color and yes, no, or something. It's not that way, right? So it's very different. And the way you operate my data as the attribute value pair and the way you operate the photo is also different. Not in terms of the technical detail of how the tool will process, but even the requirement of processing is different, right? Okay, the constraint means the constraint you impose on the data, such as if it is attribute value-based data. You may want to constrain that in my, this is employee example, right? In my company, by labor law in Thailand, for example, I'm not a good lawyer, okay? I'm not studying law. So what I give is just a random example, okay? Suppose the labor law says that you can hire anyone only when he or she is older than 20 years old. Then we need to have this constraint that anyone we store in our database as our employee cannot be younger than 20 years old. Something like this. This is also an example of the constraint, which is very much application specific. But there are both application specific structure, operation constraint, and also the very specific to the model itself. Okay, we will learn in the detail, but this is just to let you know that when we talk about data model, and we talk a lot in our class, what does it mean? It means the structure of the data that we want to model. It means the operations we want to do with the data. It means the constraints we have to impose on our data. And we will talk about this from the next class. I think we don't have enough time. When we talk about the structure, there are very well structured data. We can classify further into 3 categories. Well-defined structures, semi-structured, unstructured. Well-defined structure, we can have a very quick example. Relational database model. Relational model is an example of a very well-defined structure and very rigid, very fixed. Unstructured is something like those multimedia data, voice, video, image, application file, .exe or something. But there's still data, right? You can store it. Semi-structure is something in between. It has some structure, but it's more or less very flexible. Those flexible structure, not very fixed. When it is well-defined, it's very fixed. When it is semi-structure, it allows some change and flexibility. For those who have some experience, I will say HTML documents, XML documents, JSON documents. These are examples of semi-structure. The structure can still be changing, but still it's some kind of attribute value pair for some of them. But the pair of the attribute value can be changing. Some of the data has this, some do not have this. So it's not very fixed structure that you can always predict. But still it has certain structure, not like the video, image, and so on that has no structure at all. So the way to process those different types of structure are really different, right? When you have well-defined structure like name, age, date of birth, and so on, attribute value pair, you can manage them somehow, process them somehow. When you have very unstructured, you process them differently, right? As I said. So this is more or less our introduction for today, and we continue next time. This is the slide we have discussed last time. I think we were up to the data modeling. And actually, once you have practiced some of the lab, you have, especially those who have some background knowledge in terms of using database technology already. This is not new, right? But it's just that when we say and use or refer to the term data model, what do we mean? That is what I discussed last time. So from the data model and data modeling, we are talking about defining. Sorry, I need to. Okay. In terms of data model, we need to think about three things, right? Three characteristics of the data. That is the structure of the data, the operations we want to do with the data, and then the constraints part. How do we define the conditions and constraints of working on such data? And different types of data would have these different characteristics very differently. Okay, and that is the reason why we need to learn quite a number of data models in our class. In our subject of DMM, we will learn not only one single data model, but we learn quite a number of them because they are useful for different types of structure, operations, and constraints. Okay. I think we talked already about the structure, right? When it is very well structured, that means the structure is well defined. Your data has very fixed, well defined, and not very much flexible, right? It's so fixed, such as if you want to restrict and say that employee in our system, in our organization, every employee we model in a way that it must each employee must have first name, must have last name, must have date of birth, and the data structure or the data type for each of them is fixed and defined, such as fixed text character, string, date of birth, dates of birth must become date or timestamp, something like this, okay? And the operations mean what would you like to do with the data? The constraints would be how much the conditions, the accuracy, what are possible values you would like to allow for each of the data values, something like that, okay? And I think we already discussed this last time, right? I recap a little bit. Then when we focus on the structure part, we can see that there are data with very well structure, has rigid structure. There are data in another extreme, perhaps, which is unstructured. There are some kind of data which is semi-structured, okay? And different model structures, of course, different data model that we will learn can handle this differently. Okay, I will not go into that detail, I already explained, right? Okay, let's look a little bit more on some of the other aspects. Okay. In this example, okay, this is easy. If we talk about this, only this example that you see, sample of the data, according to the structure characteristics, considering the structure, do you think it's structure or unstructured or semi-structured? What is it? Yes, structure, right? It's well structured. When it is structured, it means it is well structured, because every of the records seems to have follow similar fixed structure, such as what you could guess would be referring to our previous example, right? First name, last name, date of birth, and everything, every record follows exactly this structure. While when we talk about the second one, maybe we could see some variation a little bit, but still, what do you think? Should we say structure or not? What do you think? Some would think about semi-structure. Someone said like unstructured because the position of data is different. Okay, we have two answers now, semi-structured and then unstructured. What do you think? How about structure? Nobody say structure at all? No. It could be very much more towards semi-structure, but actually when we say something semi-structure, it has more flexibility than this example. So I could say that if you say structure, it's also acceptable. Okay, it's also acceptable to say this is structure, but not very fixed compared to the very first one. But there are some small variation only, right? First name, last name, date of birth, this is still fine. Here, the third column, we expect something like maybe job position, right? And then perhaps I would guess salary, okay? Then this is pretty much predictable and understandable easily. And what you learn in SQL or relational model, this kind of structure is there, right? And even some of the missing thing, but of course, I think you know that we should be very fixed, right? That when the position, I mean the column or attribute We cannot like skip like this. We need to really define the now value or something and then follow the order, the sequence of the attribute strictly. Okay. And for this one, the last value is also missing. Okay. But this one, what do you think? This is really unstructured, right? I think you agree. There's no structure you can guess, predict, and understand at all. This is kind of binary file, compressed data such as JPEG images, MP3, MP4 file, or executable program, executable file, or something like that. Such kind of thing. So there is no structure that you can understand easily inside the value of such a data. So for sure, this is unstructured data, no structure at all, okay? And then in terms of the operations, I think you learn SQL a little bit, and even in your previous studies, many of you from the quizzes, we could see many of you already have good background in SQL, okay? And that means you know about all these operations. When we talk about this name type of operations, they seem to be very general, but you should be able to relate to how you do it in the SQL. Main operations in terms of manipulating data could be considered as subsetting, substructure extraction, union, and join. For example, subsetting means the whole data comprise this many. We want only selected certain subsets. But of course, you may want to do some kind of filter, right? We filter that we want anything with the fifth, 1, 2, 3, 4, yeah, more or less with the fifth column, with the last column having the value less than 90,000. So this is subsetting. But of course, in SQL, you may call it differently, right? But in general terms, these types of operation means you just select certain subsets of your data set. Another type of operation is substructure extraction. And this is very clear in SQL as well, right? You only project or select, choose certain attributes. It may, your table, you may have 100 tables in your database. You may have, each table may have many attributes, but now we are focusing on only the table, one particular table or relation, which is employee, for example. And for the employee, we are interested in only the first name and last name, right? And then we want to manipulate something from this extracted data, okay? And union, of course, you may need to combine data from different tables, different sources, and then merge them. That is kind of union. So when I refer to certain specific data model, such as relational, then you can understand, right? But in general, these can be applied to other types of data models too. But since we are now we are learning also the relational model, that is why I relate it back to the relational model. But in the future, when we learn about NoSQL, I wish that you would do the same, right? To refer and relate those types of operations that we will learn in the other kind of data models too. So this is union. We are kind of integrating data collection from 2 or more data collections together into a new one. Join is a little bit more complicated, and I think you would have a lot of you would need to practice a lot in the lab part. when we have data from more than one collection, when we want a given data from more than one collections, we need somehow to integrate them, but not just like to append them together. But there are certain ways to join them, okay, such as based on certain equivalent value of some attributes. Okay, that is what it means by joining. And in other data model also, they have some kind of join-like operation, not only in the relational and SQL language. Okay, when we talk about data model constraints, of course, they are kind of logical statements. They are kind of conditions that are imposed on your data, either in terms of the data structure or the data values. Okay. For example, we may want to impose that every data record for a movie, suppose we are maintaining movie database. Okay. So we want that every movie has only one title. We should not allow more than one title. The same, for example, if we talk about students, suppose I'm modeling and maintaining data about students, I may want to say that every student should have only one date of birth. I don't allow you to tell me 2 birthdays, right? Okay, something like this. And I may have some other restrictions or constraints and conditions on data, or even the organization, or we call business rules, may have these kind of data constraints as well, such as when we talk about grade. If data model constraints usually talks about, it could be on the structure, it could be on the values. I mean, the constraint could be on the data structure, the constraint could also be on the data values, and could reflect and model business rules. And example, if we talk about the business rule of AIT system in terms of learning system records, I mean, learning performance records. Grade system at AIT, I think you all know, but of course, different university may have different grade systems, right? At AIT, what is the grade system? If it is a letter grade, it is A, B plus, B, C plus, C, D, and F. These are letter grade systems, and it has some kind of equivalent numeric value for some kind of grade point calculation, right? Such as A is equivalent to 4.0, B plus, and so on. Oops. Different university may define and model this differently. So that is why this is also part of the constraint. Because when I enter the grade for my subject, for each student, I am allowed to only enter these valid values. I cannot say that my grade is X for some of you. No, it's not possible, right? This is example of also a constraint on the value. So it's value constraint. Or even each student has CGPA, right? And CGPA, cumulative grade point average, should be between 0.0 to 4.0 only. You cannot go beyond this range. This is also constraint on the value. Okay. So yeah, types of constraints could be value constraints, could be uniqueness constraints. So try to map this when we learn in the lab, right? For SQL and relational model. How do we impose all these constraints in the data model? Cardinality constraint, that means how many possible values a person or an entity could have, as I said, how many age value a student could have? Single, right? You can have only one single value for your age, but you can have multiple values for the course you register, right? You can register many courses, but you can only have one age, one date of birth, one name, one email in our system, in our record. So this is example of cardinality constraint. For uniqueness, oh, sorry, I forgot to say. It must have a unique value for certain things. A certain value must be unique, something like that, such as an ID for identity purpose, identification purpose. Okay. And another type of constraint could be data type constraint. Age must be numeric and positive integer only. For example, we don't record negative value for age, right? Something like that. Domain constraint, possible valid values within certain enumeration list. And also, as I already said, mentioned, another type of constraint could be structural constraint. Constraint on the structure of the data. That is, for example, every student must have ID, name, date of birth, nationality. Suppose like this. I impose the structure on the data for students. I don't record something beyond this, for example. Okay, and then I think we will learn we will move to this later on, but this is example of semi-structured data. We will learn in detail after we finish the very well structured data that is relational model. We learn about semi-structured data model. How do we handle them? How do we manipulate them? What is the structure? What is the operation? What is the constraint we can do with such kind of semi-structured data? Okay. So example of semi-structured data would be XML document, HTML document, and JSON data. These are popular examples when we talk about semi-structured data. And we will learn how can we handle such data, which data technology should be used, which tool, which query language, operations and constraints we can do on such kind of data. Okay, and actually we talk about this later in detail, but if we look at semi-structured data, and if you have computer science background, you may learn about data structure subject, right? And I think we do have such a course offer in this semester too. And in the data structure course, there's one type of data structure which is called tree. A semi-structured data could be generalized and abstracted as having tree structure. When the root of the document, of course, having kind of children, so this is the root. Each root has perhaps certain level of child nodes or children nodes, right? And so on. But we will talk about that later when we discuss about semi-structure in more detail. Okay, I should talk about this because then we will move to more detail on relational model and the design of relational model. We need to understand a little bit. Sometimes it's very useful, okay, to know the history and to understand past, present, and future. So you can see the trend, how technology is moving towards. Okay, I believe you were not born yet until here. Okay, So it is very likely, right, that these all are technologies that were invented, used even before you were born, right? Okay, so we have hierarchical model, network model from the very beginning when we deal with data in computer. So those times computer systems are still very early stage, right? Okay. Then in 1970, there was an invention of what we call relational model. That is what you are learning now, right? In the lab part, the relational model. The good things, benefits, or key benefits, key characteristics of relational model is that it allows ad hoc queries. You can query the data using SQL easily. It allows it uses set-oriented access mechanism. It has weak semantic content and so on. But from this, actually, database technology has become, we can consider it as the very beginning for the rising of database technology. That means the invention of relational model. Next, later on, we have in entity relationship model. It is defined to make it easy to model the data, understand relationship among the data, and actually has very much work together. When you use relational model, we usually use ER as well, entity relationship model, and it incorporates more of the semantic into the modeling. Okay. Then later on, we move a little bit, okay, to the next phase, next era after relational and ER. We move to the era where more of the semantic has been introduced into the data modeling. Complex objects should be there, inheritance and behavior of the data objects are modeled. And that means they are there in, for example, object-oriented model, okay, such as the class diagram in the object-oriented model in UML modeling. Okay, we do model objects and data, not only for the data part, but the behavioral part of objects too. So it is the time that we started to model complex objects and considering data and behavior of the objects together, and introducing the concept of inheritance as well. And in that case, we have object relational model too. Okay. And then how about NoSQL? NoSQL is the next evolution and the current one as well. NoSQL is a general term that refers to any data model that is not relational. Yeah, so that is why it used the word NoSQL, because we started to have what we call big data. When the data is so huge and massive, certain technology, especially relational model, may have limitation in the sense of scalability, performance, and several other issues. And many of the companies start to develop, invent, and come up with some other technologies that is not only relational and SQL. So instead of having a very relational model, is very well defined the data itself is has well-defined structure, very well-defined structure. So it fails or it has a lot of problems when your data has flexible structure. It does not fit well to use relational model, to allow flexible data structure, to allow certain variations within the data values and so on. So that means, for example, this kind of data would be very difficult to model using relational technology, but there arise such kind of data more and more. So there was a strong need that some other kind of data technology and data model should be developed in order to address such huge data and flexible data model. Okay, and that is the reason of the NoSQL to be used. Okay, so it addressed big data problem, huge data management. Some data has less semantic and flexible structure. We may consider something that is called schemaless model. Some data has no schema. You cannot say that every data has fixed schema, like every student must have name, date of birth, and so on, like that. Okay. Some data has the nature of fixed schema. Some data has no nature of fixed schema. Okay. Okay. And then I think, okay, I think I move to another part.